So example 7 says consider g of x equals x squared plus 3x minus 40 over x squared minus 3x minus 10. List the x values where g of x is not continuous and classify each type of discontinuity and write the intervals over which the function g of x is continuous. All right, I'm going to start by factoring. When I first factor, I personally jot down domain. So now I can cancel. So I have a vertical asymptote at x equals negative. Oh, my screen went gone. Okay. Thank you. There we go. All right, so I have a vertical asymptote at x equals negative 2. So that means I have a non-removable discontinuity at x is negative 2. Then there's a hole when x equals 5. So that's a removable discontinuity at x equals 5. It didn't ask me to find the hole per se, so I'm not going to do that even though I could. And then it says write the intervals over which the function g of x is continuous. Well, that's going to go negative infinity to negative 2, union negative 2 to 5, and 5 to infinity. Now, something that is considered a given in AP Calculus is that polynomials are continuous everywhere over their domain. Rationals, okay, even though you have vertical asymptotes, it is known and accepted that even if I have a rational function with the two branches, the branches are continuous over the allowable domain. Radical functions and trigonometric functions are continuous in their allowable domains. So you don't ever need to, come out and prove that or anything of that nature. All right, so number 2, we actually did this one. So that's just a typo on my part. So here's 2 problems we're going to look at. it says in number 1, determine all x values from -7 to 6 where the function is not continuous. Did we do that one? No, it's a little bit different from the other one. Okay. So let me give you a moment and write down, where is it not continuous, and is it removable or not removable? And you're not talking about the endpoints, okay? So at x equals -3, it's removable, there's a hole. At x equals 2, it's non-removable, it's a jump. X equals 4, that's non-removable, it's an asymptote. At x equals -7, that is a jump as well. But that's also like the end of the graph. All right, in number 3, on what intervals is the function shown to the right continuous? Well, we have a hole in the graph at x equals -2, so we would say -infinity to -2, union -2 to infinity. State which part or parts of the definition is violated at the discontinuity. So remember the 3 parts? Which part? So what was the first part? Can you look through the notes? What was, and we had it in a table. What's the first part? Yeah, Zach?
F of x is defined.
Okay, so is f of -2 defined? Yes, okay, so that's met. What was the second criteria? Abby, do you remember what was the second criteria? Look through your notes there. It was in the box on the first page.
Oh yeah. It was the limit must exist.
Okay, so, Ankit, when I look at the left and the right coming in from x equals -2, does the limit exist?
Yeah.
Yes, it does. Then, Leah, what was the third criteria?
The limit has to equal the x value.
Good job. Okay, so here, it was the third part that got violated. It was the limit does not equal the function value.